Hello everyone, I think everything is going well with you. In this lecture series, I would like to discuss about the basic physics for engineering students. The subject is applicable for any branches of engineering like CSE, EE, ECE, civil, mechanical, biotechnology and so on. In this lecture, before going through in detail study of the mechanics of a single particle, I would like to motivate you to ask the question that do you really need to study the mechanics or physics as an engineer? For example, let's say you are a student of CSE department. That means you want to become a computer engineer. So do you think you really need to study the physics or mechanics? Let's think very carefully. So if you want to become a computer engineer, I think you should know everything about the computer. And if we broadly classify the computer in two parts, that is the software based and the hardware based. And if you go through the hardware part, you will find some sector where you have to deal with the motion of the objects. For example, if you consider the hard disk, it is a magnetic disk which is rotating around an axis, and if you want to analyze the motion of that hard disk, you should go through the angular movement or angular motion. That means you should know the angular velocity, angular acceleration, angular frequency and so on, and it is a part of the mechanics. Now let's say you are not interested in the hardware part, but you are interested in the software part. And the software part, you are now doing one programming of the Prass motion to visualize the Prass motion. Now to do the program, you need a basic equation for the Prass motion, and if you don't know details about the Prass motion, it does not matter, but you will be able to do the program. But if you know the basic behind of this Prass motion, then it will be much more entertaining to you to do the program. And this is true for every branches of engineering, that if your basic is strong, then you will be very successful in your engineering subject. And as we know that mechanics is a science of motion, of the material objects, that is, it deals with the motion of the terrestrial object to the celestial one, and it is divided into two parts. One is the kinematics and another one is the dynamics. In kinematics, we analyze the motion through certain parameters like the displacement, velocity, acceleration, and to do this we don't need to care about the cause of the motion. If we take one equation, that is S equal to ut plus half ft square, and I think we are all familiar with this equation, where u is the initial velocity, f is the acceleration of that object. If you know this u and f, you will find the displacement of that object at any time t. If we take another equation, that is v is equal to u plus ft, where u is the initial velocity, f is the acceleration, and you know both of them, then you will find the final velocity of that object at any time t. And to find out these parameters, we don't need to know the cause of the motion, we need only to care about the motion of the object. But when we are dealing with dynamics, then we must need to know the cause of the motion. That means when an object is in motion, then we can guess that there must be certain external force which is applied on that object, and to analyze the motion of that object, we have to solve the equation of motion, that is F is equal to ma, and the differential form of this equation becomes F equal to m d2r dt2. And if we have the explicit expression for the f, by solving this equation we can get several parameters like the position, velocity, acceleration and so on. In this course we will discuss about the dynamics of a single particle or system of particles, and along with we would like to discuss several conservation laws like linear angular momentum conservation, mechanical energy conservation laws and their importance. So first we'll discuss about the Newton's laws of motion. But before going through in details of the Newton's laws of motion, would like to define very important term which we frequently use, which is the particle. What do you mean by a particle? If we consider a system which is consisting several number of objects, particle is an object whose dimension is negligibly small compared to the other objects within the system. And sometimes we will use the term point particle. So what do you mean by the point particle? It is completely a mathematical idealization, because we know the definition of the point is that it is a dimensionless entity. So when we consider the point particle, it should not have any dimension. So it is completely mathematical concept, but for convenience in physics we will use the term point particle. For example, when we are considering the motion of a bus, then we can replace the whole mass of that bus by a point mass, which is called the center of mass. Then if we want to analyze the motion of the bus, it will be enough if we just analyze the motion of the center of mass. So point particles concept becomes very important to replace whole object to a point. Now we move to the Newton's laws of motion. As we know, there are three laws of motion which are the backbone of classical mechanics. First, consider the first law of motion, which states that when a body which is at the rest condition, it try to remain its present condition unless we will apply some external force to change its state. Similarly, if an object is in motion, if we want to stop it, then we have to apply certain external force against the movement of that object. So without applying any force on the object will stay in its present condition, and this is the first law of motion. Sometimes the first law of motion is called the law of inertia, because inertia is such a property by which an object would like to remain in its present state. That means if an object in its the rest condition, it would like to stay in the rest condition, and if it is in the motion, then it try to continue this motion. That's why the first law of motion is sometimes called the law of inertia. Next, move to the second, and it says that the time rate of change of momentum of the body is proportional to the external force, which mathematically can be written as, that is, dp dt is proportional to F. Next, move to the third law of motion. As we know, and it is very familiar to us, that is, every action there must be some equal and opposite reaction. Next, we will move a very important concept which is called the frame of reference. For example, let us consider a train is passing through a station. There are two observers, one of them is inside the train and another one is at the station. Now, according to the first observer who is inside the train, he will say there is no motion relative to this observer and the train. That means, according to him, the train is at the rest condition. But if we consider the second observer, he will say no, there is a motion of the train relative to him. That means the present state of the train, that is it is in the rest condition or the motion condition, it completely depends on the observer points of view. That's why Newton's first law of motion involves the concept of frame of reference to which the state of rest or the uniform motion of the particle is observed. Frame of reference is divided in two parts. One is the inertial frame of reference and another one is the non-inertial frame of reference. According to the definition, what is the inertial frame of reference? It is a frame of reference where Newton's first law of motion is valid. Similarly, non-inertial frame of reference, Newton's first law of motion does not valid. So if the law is not universally accepted, how it become a law? It becomes a law because if we consider Earth as a frame of reference and we want to analyze the motion of the object with respect to the Earth, then it behaves like a inertial frame of reference, and Newton's all laws are equally valid in this Earth frame of reference. But strictly speaking, Earth is not an inertial frame of reference because there is a spin motion about its own axis, and it makes it as a non-inertial frame of reference. But if we approximate this non-inertial behavior to inertial one, there will be no problem to analyze the motion of the objects in this Earth. That's why we can say the first law of motion is a law. Next we move to the second law of motion and conservation of momentum. For that, let us consider an object which is moving along this path. The position vector r at any time t is explicitly given in this figure. Now, according to the Newton's second law of motion, the equation of motion becomes F is equal to ma, where a is the acceleration of the object and F is the net external force applied on the object. So what do you mean by the net external force? That means if we consider the motion of an object, there may be several numbers of forces acts on that object. Maybe there is a gravitational force, electromagnetic force, and there are large number of known unknown forces may act on that object, and due to the effect of all that forces, the object is moving along a path. So this F is the vector sum of all that forces. So now F is equal to, we can rearrange the first equation, and F is equal to m dv dt. As we know, the acceleration is nothing but the rate of change of velocity, and we could rearrange this term as ddt of mv. We can take m inside the parenthesis because classically m is a constant quantity which is the mass of the object. Since momentum of the object p is equal to mass multiplied with the velocity, so in place of mv we can write the momentum p. So the equation becomes F is equal to dp dt. Now let's say if anyhow the external force, that is the net external force or net applied force F is equal to 0, then from that equation we can directly remark that dp dt must be 0, and which says that p is a conserved quantity or the momentum is constant. So this is known as the conservation of linear momentum. Now what is the importance of that conservation? Let us consider an object is moving under several forces. That means there are large number of known and unknown forces are acting on that object, and if we want to find out the net external force or net applied force, then we have to add all these forces vectorially. Then, but if we have certain information that the momentum of this object is constant, then we don't need to care about all the externally applied forces. We can directly conclude that the net external force or applied force is 0. So our calculation becomes very easy in this case. So this is the importance of the conservation law or conserved quantity. Next we move to the conservation of angular momentum. As we are familiar with the definition of the angular momentum, that if a particle is moving in this curve and its velocity along this direction, that means the momentum is also along this direction, and the position vector r is given here, then the angular momentum L is perpendicular to the xy plane, and which is expressed as the cross product between the position vector and the linear momentum of the object. There is another important definition, which is the torque. As we know, the torque is nothing but the momentum force about a fixed point, and it is defined as n vector, which is the cross product between the position vector and the force. We can easily understand the torque through this diagram, that if this is an axis and this is an object, if we apply a force along this direction, and if it is the distance between the axis and the object, which is r, then the torque will be acted perpendicular to both force and the position vector, and it is written as n vector is equal to r cross f. Now we can directly write, that is n vector is equal to r vector cross dp dt, since we know from the Newton's second law of motion f is equal to dp dt, that is the rate of change of momentum. And we could write this equation as n vector is equal to r vector cross ddt of mv, since the momentum is equal to mass times velocity. Now we have got the relation, that is the n vector, that is the torque is equal to r cross ddt of mv, and we can directly write this form as n vector is equal to ddt of r cross mv. So let's check how these two expressions are equivalent, that is r cross ddt of mv is equal to ddt of r cross mv. For that we analyze that ddt of r cross mv we could write it as the differentiation of the r vector first, keeping mv constant, and then keeping r constant and differentiation on the mv. So we will get ddt of r cross mv is dr dt mv plus r cross ddt mv. Now as we know, dr dt is nothing but the velocity, so it gives you v vector cross mv vector plus r cross ddt of mv. And if we take m out of the parenthesis, we will get the first term as v cross v plus r cross ddt of mv. So ddt of r cross mv, since v cross v gives you 0, as we know the cross product of the same vector gives you 0. So ddt of r cross mv gives you r cross ddt of mv. So if we observe this equation, where we get n is equal to r cross ddt of mv, so in this position we can write ddt of r cross mv. So now the torque becomes ddt of r cross mv. As we know that mv is nothing but the momentum of the object, so we can write here the torque is equal to ddt of r cross p, and initially we have seen that the definition of angular momentum L is equal to r cross p. So we can write this r cross p as L, and hence the torque gives you dl dt. Now similarly the conservation of linear momentum, here if anyhow the net external torque becomes 0, then this equation gives that dl dt must be 0 and L is a conserved quantity. Next move the another conservation law, and very important one is the energy conservation law. Here energy means we are dealing with the mechanical energy. Let us consider a particle of mass m moves from one point to the another under the influence of conservative force. Let us consider a particle of mass m which is moving from the point 1 to point 2 under the influence of conservative force. So first let's say what do you mean by the conservative force, and for that if we think that the particle will move from the point 1 to point 2 through three different paths A, B and C. If the work done by the applied force on the particle does not depends on the path, that means when the object is moving from the point 1 to point 2, if we want to calculate the work done and work done remains same for each and every path A, B and C, then the external applied force is called the conservative force. And we are considering that the particle of mass m is moving under the influence of conservative force. So let's try to find out the work done by this conservative force. As we know from the definition of the work done, that is W is equal to integration of f dot dr with the limit 1 to 2, and we could rearrange the integrand as f could be written as m dv dt dot dr is v dt, since we know that v is equal to dr dt. So in place of dr we could write v dt. So if we rearrange all the terms again, then we can take m outside the integration because it is a constant quantity, and inside we can write it is v vector dot dv dt. So it gives you m integration 1 to 2 v dot dv, and it is nothing but v dv, since the dot product of the same quantity gives you the scalar multiplication only. So now our work done W becomes, if we do the integration, so it is m v square by 2 from 1 to 2, and W becomes half m v2 square minus v1 square. As we know from the definition of the kinetic energy T, which is written as half m v square, then if we write explicitly the work done W, then it is nothing but half m v2 square minus half m v1 square. So it could be written as T2 minus T1, where T2 and T1 are the kinetic energy of the object at the point 1 and 2. So now the net work done becomes the change in kinetic energy at the 2 points. Now we would like to find out the work done in terms of the potential energy. As we know, since the force applied on the particle is a conservative force field, then it could be expressed as a negative gradient of the potential. So if F is a conservative force field, then F could be expressed in terms of the negative gradient of the potential. And we know what is the geometrical interpretation of the gradient. We have discussed in the vector calculus chapter already. So now W becomes f dot dr, that means minus gradient of v dot dr, and if we write the gradient of v in the explicit form, then the negative sign is outside the integration, and in the integrand becomes del v del x I cap plus del v del y j cap plus del v del z k cap dot dx I cap plus dy j cap plus dz k cap. And if we do the dot product, then we will find it becomes, and if we write here the dot product, it gives you del v del x dx plus del v del y dy plus del v del z dz. That means the integrand becomes dv only. So if we do the integration, you will get w is equal to v1 minus v2, and it is the same w where what we have found previously, that w is equal to change in kinetic energy T2 minus T1. Now the same w is v1 minus v2, and if we make equal, then we will get T2 minus T1 is equal to v1 minus v2, or T1 plus v1 is equal to T2 plus v2, and this is the conservation of energy. So through this lesson we have discussed what is the importance of mechanics for any branch of engineering. Then we have moved to the discussion on the dynamics and Newton's laws of motion. What is the definition of particle? Then we have moved to 3 laws of motion. What is the concept of frame of reference? And we have discussed the linear momentum conservation and the second law of motion. And if we ask here, what is the condition for the linear momentum conservation? The condition is that dp dt should be 0 when f is 0, and then the linear momentum would be conserved. That means when the net external force or applied force on the object is 0, then there will be a linear momentum conservation. Similarly, if we ask you what is the condition for angular momentum conservation, then you should say if the net torque applied on the object is 0, then we will find the angular momentum is a conserved quantity. Similarly, for the energy condition for energy conservation, that is the object moving under an external force, and if it moves from the point 1 to point 2, this external force must be the conservative force field. If an object moving under the conservative force field, then its energy must be conserved or constant quantity. So in the next lecture we will discuss another topic. Thank you for your attention.